All right, so let's start with the subject documentation. I'm sure you must be asking yourselves or considering that the subject is theoretical in nature. Sadly, it is not. Except for GCC, everything involves some form of calculation. Okay, so what is documentation about? Up until now, you've done numerous subjects within this degree where you were tasked with designing something, a road, pipe network, structural member. Now, documentation 3 is not about designing any structure per se. However, it is about designing a tender document. Remember all those items that you've designed with calculations, they actually mean nothing unless they have documentation attached to it in the form of a specification. So we're going to be doing that portion, all right? Putting in a specification, putting in some instructions to make that design of yours into something that can be followed by another construction professional. All right, now let's look at the breakdown of the subject itself. I'm beginning with estimation. Estimation in your final exam carries about 25 to 35 marks out of 150 marks. GCC carries about 12 to 16 marks, and the remainder is dedicated to quantities. So that will give you an idea of the importance of quantities in this subject. All right, so let's start with estimation. All right, estimating involves knowledge of the following. Average output of mechanical plant per hour. And when we say mechanical plant, we're talking about all those yellow vehicles that you see building roads, digging holes and trenches, and grading the road. All right, so that's the mechanical plant we're talking about. We're talking about graders, TLBs, rollers, tipper trucks, excavators, right? And we look at those as we progress, right? If you don't know what they look like, we're coming to that, so relax. Average output of labor per hour, skilled and unskilled. So who would you consider to be unskilled labor? All right, we're talking about people, labor, we're talking about unskilled. All those individuals that basically do general work or general workers that do the stuff by hand, do the activities by hand, wheeling a barrow, loading sand, mixing daga, the daga boys and all those kind of things. So who's your skilled labor? Your skilled labor would be your artisans. Your artisans being bricklayers, plasterers, and the like. All right, a knowledge of construction economics. Now we're just starting out in this business. So what knowledge do we have? We don't have. What we do have is a history from the past. And that's where that comes in. And now, why is weather conditions an issue in estimating? It is a big issue. Okay? Because if the weather does not permit outside work, your plant will stand. These guys will stand, chalking up hours and costing you money. Right? So weather conditions are an issue. An estimate is produced from a combination of experience and recorded cost data. Right? Remember what I said there. Of similar works carried out previously, data are best recorded as hour constants, the plant and labor hours taken to produce a unit of work. We'll expand on that in a moment. Estimating is essentially a practical exercise, and the estimator is required to examine the drawings and schedule of quantities, visit the site, produce an estimate based on progress and economics. The estimate is required to calculate the cost of unit and preliminary and general P&G items. This will take up considerable amount of your time when you start working, and quite a bit of money is located under these items, known as P's and G's. What is it? Let's look at it. Prepare the final estimate and submit the tender. Unit rates are based on quantity, schedule of rates, specification, SABS, we'll come to that, and the type of work drawings. P&G items are general costs that cannot be priced directly against specific unit items. What do they mean? Cannot be priced directly. It simply means this. If you've traveled past a construction site and you've seen a big sign there of what activity is going, or what structure is coming up, who the client is, who the architect is, who the electrical contractor is, right? You saw the sign. Who puts that sign? And how do you pay for that sign in the tender document? This is where you pay for it, under P's and G's. You provide a description of the sign, and the contractor has to basically have it made up and placed at the spot that you indicated. And the cost of that is now located within the tender document in the line items under P's and G's. All right, that not may be clear. Think about another item, water. Can you quantify water on a construction project? Can you quantify the amount of water? Do you know exactly how much of water you're going to be using to construct this structure? You don't. It's virtually impossible. So how do we quantify water to say, right, we're going to need X amount of money for just that one line item being water? So we'll take a percentage of that contract value, maybe 1%. If the contract value is 1 million rand, you can work out how much of water you're going to be using. General ballpark figure. And suddenly we have a number to put into our tender document. All right, so think of those items that you can't physically quantify and locate it in your P's and G's. Elements of the cost. Unit costs are built up from the cost of labor, plant and materials. P&G items include inter alia establishment charges, basically to bring your offices to this new construction site. Insurances, holiday pay, subsistence allowance. Subsistence allowance, what's that? If you, upon graduation, work for a construction company and they want you to go work somewhere in Pietermaritzburg or somewhere in Port Shepstone, you get an allowance to go and stay out there. All right? A lot of money in here for you guys when you start working if you're in construction. All right, transport, time and travel, access to plant haulage, water, we spoke about that, supervision, small plant, tool security, temporary roads, hoardings, traffic control. So all our items, notice, none of these items have got to do with what you're building. You could be building a school, you could be building a hotel, but all these items are common to those different types of structures. How do you pay for it? This guy. You pay for it in P's and G's. All right, we'll come to what a bill of quantities looks like, and then you will see the location of the P's and G's and how the money is located in the tender document for these or for all of these items. All right, let's move on. Labor cost. There are two groups of labor, skilled, which is artisans, and unskilled, as I've already discussed. The labor cost is based on the total cost to the tenderer, basic hourly rate plus benefits. Approximate rate, now these rates are very old, very old. Current rates we're looking at, depending on location, we're looking at basically 150 Rand per hour for unskilled. All right, sorry, labor, 150. And this being depending what the artisan is, either a plasterer or bricklayer, we're looking between 300 to 400 Rand per hour. Just to give you an idea of their costs. Don't worry about these numbers, we're not going to be using them. All right. Right, the principle of calculating a labor constant. One artisan and two laborers to build 1 square meter of brickwork in 2 hours. So let's understand this. In 2 hours, this skilled person needs 2 of them to do that amount of work. And we arrive at a labor constant of 2 hours per square meter. What is the labor cost of that activity? 1 times your artisan and 2 times your laborers gives us cost. Where did I get these numbers from? I got it from there, and I got it from there. All right. Now, this example is to give you an idea of how we arrive at costs per hour. That brings me to another important point for estimation. Everything or every calculation we do is going to be reduced to cost per hour. Cost per hour. All right. So try not to lose sight of that as we progress. Labor constants are established historically. Remember, I said we don't know, we're using the past over a number of years to get these kind of numbers. For example, 6 laborers excavate 22 cubic meters in 1 8-hour day. Now that's a given. We found that out over the years. If you got 6 guys, they can do 22 cubic meters in 1 8-hour day. Labor constant, therefore, 6 times 8 divided by 22, and it gives us 2.18. Right, materials. Cost is based on quotes from suppliers. Prices include basic supply costs, transport to site, handling, etc. Ensure that materials meet specifications, include a wastage factor for losses, for breakages, and they range for that. And we'll touch on calculations for waste factor for mortar, concrete, bricks, as we come to our calculations. All right, P's and G's again, insurances. Now let's break down P's and G's into some of the items that it is composed of, and let's try and understand how it works. First one, insurances. Third-party public liability is usually specified in the tender document. So it's specified in the tender document. So it simply means that the construction company has to take out third-party public liability insurance, which simply means that he needs to insure the site for various items, such as theft and breakages and whatever insurance companies think that he may need for that construction of those works. Insurance of the works increases on some predetermined sliding scale as the work proceeds. Why does it increase? Why does insurance increase for this thing? Because as the days progress, he's building more. It's become more valuable because he's putting more effort and more energy and more materials to create the structure. Therefore, the value is increasing. Hence, insurance has to increase on some sliding scale. Prices are based on quotations from insurance companies, so you basically at their will when it comes to the pricing of insurance. All right, water. Allow a percentage of the contract value for the cost of water, and here they're saying 0.125%. To get a guesstimate. When I say guesstimate, it's an educated guess. This is more or less how much water I'm going to need, and this is how much it's going to cost. And it also includes the cost of municipal mains connection, consumption, and temporary plumbing. All right, so municipal mains connection, basically an application has to be made at the local municipality. They come in and put in the pipes and a meter, and now you have water. All right, there is a cost attached to that. In Etegwedi, currently, as we speak, if you want a 20 millimeter connection put up by the municipality at a new residential site for a single house, the cost is sitting at 6.4. Just for them to come put in the meter and the pipe work for the site. Where will they do it? If this is your site, that's the road, that's your driveway, just for them to come here and put a meter there, there's the cost. And suddenly you have a connection, and you can basically put all in your pipes for that house. Right, small plant and tools. The estimation is done by experience based on the current cost of a percentage of the labor cost, or more or less 1%. If you have a contract value of 750,000 and you have a labor cost of 280, the small tools usually is around there. Right? Remember, it's a guesstimate. Site establishment. Now, this is very old numbers. This is not current at all. All right, this is probably 10 times as much current base costs. Consider an 8-month contract. Site offices 150 rand per month times 8 gives you that. Containers 3, you're renting it at 100 rand each times 8, and that gives you that. Portable toilets 2, and you get the idea of establishment costs for that particular job. All right, we haven't even started with what the structure is. It's just to get all our stuff on site before we start. All right, security and lighting. This includes the cost for security guards, dogs, lighting, etc. Temporary roads, hoardings. Hoardings, what is that? You know what temporary roads, right? Hoardings. You got your construction sites, and you see this green fence. They put it all around there, so you can't see what's happening. Usually, put a security guard there at the entrance. So that's hoardings. Protective screens to protect the public. Cost based on materials and our labor for erecting and dismantling. All right, once again, very old numbers. Supervision, these are staff employed on the site in a supervisory capacity and are paid monthly. Consider the same 8-month contract. You have a contract manager 30% of the time, and here's his charge for 8 months, and suddenly you have a cost for that guy and a cost for that guy. They need vehicles, and we have a cost of vehicles. We have foreman, that's his cost for the duration of that particular structure, site foreman, and suddenly we have supervision costs. Right, the cost of the contract manager, quantity, and the cars are often included under office overheads. All right, let's look at plant costs. Included in your rates, items such as cranes and scaffolding cannot be allocated to plant costs and are priced as a lump sum. Plant can be hired or owned. All hire rates are available from plant hire companies. If the plant is owned, a number of factors apply as illustrated below. Now, in some of your some of your tests, in your exams, I've given you a situation. Prove to me which is cheaper, to hire plant or to own plant. All right, and we're starting with those calculations now. How to come to that conclusion, whether it's cheaper to hire a piece of machinery or to go out and buy it. All right, so let's look at that. Depreciation. A plant has a purchase price, an estimated working life, and a scrap value. All right, before we go there, what does depreciation mean? The opposite would be appreciation. Right, so what's depreciation? It simply means as time progresses, its value decreases, like a vehicle, like a car. Unlike property, as time progresses, value of property increases. All right, a plant has a purchase price, so you buy it at the price, brand new price. Now, estimated working life. Here's something I need to bring in. If you continually fix it, right, the working life goes on and on. But for accounting purposes, the working life decreases to 0. And because it decreases to 0, it can be written off from an accounting value. It still has value. What value is that? Scrap value. It has a scrap value, which means if you buy a plant for 900,000 and after X amount of hours, the accountants, okay, tell you it is now has a value of 0 from an accounting perspective, but has a scrap value of 80,000 Rand, right? Which means it's still being used. As scrap is valued 80, but from accounting point of view, it's valued 0. A little bit something new to understand. You'll see it as we go along. So depreciation is the purchase price minus the scrap value over the working life. Let's look at it in forms for calculation. Purchase price, we bought this cement mixer for 240,000 Rand. It has a scrap value. It has a scrap value of 30,000 Rand after 10,000 hours. Now, 10,000 hours, all right, like a car, you gauge its usage by how much of mileage is done. If you look at the mileage, it's already done 300,000. Oh, this engine is not going to last long. I do not want to buy such a vehicle with so much of mileage. In the same token, a cement mixer is not a car. How do you gauge its life? How long it's running? Usually has a meter. Every time that engine starts up, the meter starts running. 10,000 hours, quite a bit of lifespan. All right, and the depreciation works out to that divided by that gives you 21 Rand per hour. So for every hour of that 10,000, you are losing 21 Rand. But you're still making a substantial amount of profit by mixing concrete and doing projects. All right. Some life expectancies, concrete mixers and pumps 8, excavators chuck 10, roses and crates. Now these numbers I will give you in a data sheet. You do not need to memorize them. Don't memorize them. I will give it to you in a data sheet. Why am I giving you a data sheet? Because you're going to need them for calculations such as that. All right, let's move on. Interest, taxes, and insurance. Interest is the money earned if the capital used to buy equipment was invested at current interest rates. So what are we saying? The capital of this, if we chose to save that money and not buy the machine, instead we went and hired it. If we chose to save that money, how much interest would we have made? Right? So do we save the money, earn a very little bit of interest, or spend that money, buy this machine and do jobs and pull in a whole lot of profit just because you have a concrete mixer? You don't have to buy ready mix, which is very costly, and all those kind of things. So those kind of things we try to locate here. Taxes include licenses and government levies. Interest and taxes approximately 10% of the depreciation. So we're taking 10% of 21 Rand from the previous page, and we say our interest and taxes is 2 Rand 10 cents per hour for the duration of that life of that vehicle. All right, repairs and maintenance. An allowance is made for keeping plant in good working condition. This is approximately 10% of the depreciation. Once again, data sheet in your test and examination. I will give you these. And naturally, you need it for calculations. Let's look at it. Depreciation of an excavator, 21 Rand per hour, allow for repairs and maintenance. We said excavator. So what is excavator? There we go. 33 1/3 times that, and you get 7 Rand per hour. All right, next one, tires. New set of tires for a lifetime of vehicle is equal to vehicle life minus 1 over the tire life. Why minus 1? Why minus 1? Remember, when you buy a brand new vehicle, be it a car or plant that has wheels, that has tires, all right? It doesn't come without the tires. That first day you drive it off the showroom or it's delivered to your workshop, it comes with tires. Therefore, it's already paid for. It's already paid for. Therefore, you cannot ignore that. Minus 1. Right? This is critical because sometimes if you forget this, and you will see now why estimation is such a dangerous topic, because every calculation depends on the calculation before. You'll see that in a moment. If you mess up the calculation before, the calculation after is based on a wrong answer. And therefore you will progress throughout that 2 pages calculation with wrong answers. Right? Estimation, not my favorite subtopic, because students don't do well when they start to make simple mistakes that cost them, because the follow-on of that example is quite long and reliant on previous answers. Right, example, a 4 cubic meter truck has 10,000 working life. Tires have 3,500 hours of working life and cost 2,000 Rand each. 2,000 Rand each for a tire. Okay. Number of tire replacements. How do we come to this answer here? So we're taking 10,000 hours, all right, divided by the tire life minus the 1, and we get 2. And we get 2. Okay. What do I do? 10,000, 3,500, 2.86 minus the 1, 1.86. Can you buy, now you realize why I'm doing this calculation in front of you. Can you buy 1.86 sets of tires? You can't. You have to buy a full set. And the next full set would be 2. Hence, you need 2 more sets. All right? Now, the reason for doing this is because of this fraction. Now, you know from your maths from preschool or school days, if it is 1 point something greater than 0.5, it goes to the next whole, isn't it? And if it is 1 point less than 0.5, it comes back to 1, isn't it? Now let's assume this answer of 1.86 was equal to 1.24. Are you going to reduce it to 1 set of tires? No. In this instant, it has to jump to the next whole number, because you still need that to run this vehicle for the duration of its working life. You need to be practical here, right? This applies to cement. We'll come to cement calculations in a moment, right? Can you buy 1.67 bags of cement? Can you do it? What is 0.67 bags of cement? I'm sure somebody is going to take out a calculation and divide it by 50 kgs and tell me, right? Now, which hardware store is going to sell you that? All right, they're going to look at you funny. You'll have to buy what? 2 bags. Think of it practically. It's maths, fine, but it's practical maths in the sense of tangible items, cement, tires, cutting discs. All right. All right, continuing with that. And we said 2 sets times 4 tires, because the 4 is because the vehicle has 4 tires on 2 on either end. So 4 tires times 2,000 Rand each, and we got a cost of tires for the duration of the life of that vehicle. Right, tire cost per hour, and as I mentioned earlier, everything is reduced per hour, 16,000 divided the life of that vehicle, and that's what it costs you per hour to own this vehicle in terms of tires. Right, now let's look at fuels and lubricants. These are present day costs. Owning cost is made up of depreciation, taxes, insurance, repairs, and maintenance. Operating costs are made up of tires, fuels, and lubricants. All right? Now, why am I saying this? Because we will have to do calculations for each one of those and each one of those to arrive at an owning cost per hour for this entire vehicle. I'm saying entire because you have to take into tires, fuels, oils, oils, depreciation from an accounting perspective, taxes and insurance, and repairs and maintenance. All right, let's stop there and we'll start with an example in our next lecture.